Good afternoon. I'm Matthew Dominic, call sign Pojo. I'm really excited to share some of the really cool things we get to do at PAX. I was a fleet JO in VFA 143, the Pukin Dogs. I then had a really great opportunity to head to grad school in Monterey. Started my master's there, and I finished it at Test Pilot School in December of this last year. And then I've been at VX-23 since. Really loving it over there, but more importantly, I'm here celebrating carrier aviation with everybody. I'm going to talk about something we call shake, rattle, and roll. In carrier suitability, we want to make sure every carrier-based aircraft and or weapon system can survive the toughest carrier landings or catapult shots. We do this by flying to the design limits of the aircraft. To put it simply, we intentionally abuse the aircraft, and then we check and see if it still works. Right now overseas, while we celebrate carrier aviation, our brethren are on the USS Bush flying daily missions against ISIS. As carrier suitability pilots, we don't want a bomb or fuse to fail. We don't want a bomb to go off target because of a previous hard carrier landing or catapult shot. When a Prowler or Growler Echo commands it, we want every bit of electronic Armageddon raining down upon the enemy. Here's how we make that happen. We have some really, really amazing test assets at Pax River. Right here on this left display, you'll see we have a runway with the runway 32, and we have a ship arresting gear system built into the runway. Cable risers, metal deck plates, non-skid, the whole works. The angled concrete on the left of the runway there is our land-based steam catapult. It's a little shorter than the steam catapults you'd find on our Nimitz-class aircraft carriers. To give you perspective for test points, we've hit 5.5 Gs. In fact, just a couple weeks ago, I did 5.5 Gs through the chest into the seat. Your typical carrier catapult shot peaks out mainly about 2.5 G. So we're doubling that and then adding some change. So here's a land-based catapult shot at Pax River. I'm telling you, it's quite a hoot to ride. In addition to catapults, we get to do arrested landings to simulate the roughest conditions we could anticipate on the carrier. Imagine trying to safely replicate the worst landings nuggets could throw at you. Then we go a little bit farther and simulate dirty hinge approaches. We fly a bunch of different types of arrested landings in order to reach the edges of the aircraft design limits. Truly precise edge of the envelope flying. Here's your video first in full speed and then at 1/10 of speed. In this test point, the pilot is intentionally cross-controlling the aircraft. He is slipping all the way to touchdown, trying to simulate a moving carrier flight deck or a lake correction. Watch as the wire whips up and yanks around on the hook and really stresses the aircraft. We want to make sure that those two bombs will still function in a later flight. In the subsequent video, we've got a Hawkeye. In this video, the pilot intentionally rolls and yaws in the same direction just prior to touchdown. Timing is absolutely critical in this test point so that you don't exceed the limits of the aircraft or the arresting gear system. Bolter, bolter, bolter. Power back on. You can see these are really, really challenging test points to fly, and we really enjoyed doing it. We also conduct something called free flight landings, and it's defined as when the hook catches the wire before the main gear touchdown. So here we go forward, and we see that the hook is just catching that wire. One more frame, and we see it's very clear that the main gear are off the deck and the hook is up. Our window for conducting this test point is about that big. We've got one wire out there, and we set the lens right on top of the wire. We're targeting it. It's a good, strong integration between test pilot and test LSO with really critical and timely, easy with it, and attitude calls. It's critical for safety of flight that we have a rate of descent during this test point. We'll watch that there. If we have a rate of climb when we do this, it's a little bit dangerous, but it's not something we try to do. We avoid this. Here he catches it with a rate of climb. It's not intentional. Of note, the airplane came out just fine on this one. The pilot had a little bit of a hurt back, but we try to avoid in-flight engagements. Another test point is the high sink. Has anybody ever here had a big high fly-through down at the ramp? Traded a high ball for a low ball? No, nobody. Everybody here flies cresters and center balls, I'm sure. In this case, we're trying to simulate that underlined fly-through down at the ramp while the deck is coming up to meet your aircraft. So we're intentionally flying a 6-degree glide slope here. We set our flaws to 6 degrees, and this is an approach at Pax River. We're doing about 12 to 1,300 feet per minute rate of descent all the way to touchdown. It's really hard not to want to pull back and avoid this landing. I love doing that. The last shake, rattle, and roll arrestment we will talk about is off-center engagements. We have to target between 17 and 20 feet. If we go outside of 20 feet, the arresting gear is down for 24 hours, and you're slowing down test for the fleet. So this is a T-45. I love how the cable jerks that little T-45 around. So overall, shake, rattle, and roll test points are challenging, but most importantly, they're a boatload of fun to fly for us. Another one of our responsibilities in carrier suitability flight test is to make sure that precision approach and landing systems found on both our